Hello everyone, I am Dr. M. Manikam, Assistant Professor at Department of Physics, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. So today in this video, I will detailedly discuss about Schottky Diode. So this is actually lecture series video. In our previous video, we have discussed about tunnel diode. So in this video, we'll detailedly discuss about what is Schottky diode, how it is working, what are all the applications. These are the things VA characteristics of Schottky diode. So these are the things we'll discuss in this video. So let's start the video. So first of all, we should know what is Schottky diode. So it is actually it's like a PN junction diode, but there's a small difference between Schottky diode and PN junction diode. So a Schottky diode or Schottky barrier diode, another name we can call it as. So it's a semiconductor device formed by a metal to semiconductor junction. So in PN junction diode, so there are two types of semiconductor metals, p-type and n-type semiconductor metals. Here only one side is semiconductor metal, another side is metal. So metal to semiconductor junction, so they are rather than the PN junction, so resulting in a very low forward voltage drop and extremely fast switching speed. So this is the benefits of this Schottky diode. So these diodes excel in high frequencies. Some of the applications like high frequency, high efficiency and low power applications, we can utilize this kind of Schottky diodes. So for example, you can sell power supplies and solar cell production through they generally have their reverse leakage current. So these are the some applications of Schottky diode. So let's uh, uh, discuss in detail. So this is the symbol of this Schottky diode. So it is similar to normal PN junction diode, but there is some difference in the symbol. So one side is anode, another side is the cathode. So the symbol of Schottky diode when compared to the normal silicon PN junction diode. So left side black color, that is the PN junction diode. So two PN junction diodes are joined. Then second one is the Schottky barrier diode symbols. So the definition for this fundamental definition for this Schottky diode is a unipolar semiconductor diode formed by joining a metal electrode with an N-type semiconductor. So this is the Schottky diode. Then advantages, core advantages of this Schottky diode is sustainable, substantially lower forward voltage drop VF, that is voltage forward voltage, than conventional silicon diode. So this is the main difference between the conventional PN junction and this Schottky diode. So extremely fast switching speeds with virtually no reverse um, recovery time. So this is the main advantage of this Schottky diode. Then for higher reverse leakage current and generally lower maximum reverse voltage ratings, typically it is less than 50 volt, like that we can operate. So anatomy of this metal semiconductor junction, that is Schottky diode. In standard PN junction diode, so p-type metal is there, n-type metal is there. In between there is a depletion layer, large depletion layer is there. There is a bipolar operation, holes and electrons, charge carriers in PN junction diode. But Schottky diodes MS junction, one end is metal, another end is semiconductor material. So it is unipolar operation, only electrons here plays the role. So here the arrow mark indicates the electron flow, direction of the electron flow. So this is the difference between bipolar and unipolar. So the conventional diodes rely on both holes and electrons, that is bipolar. Here in MS junction diodes, that is only one electrons will play the role. So in Schottky diode there is no depletion layer, so zero depletion layer. Then due to this zero depletion layer, the result is maybe conduction stops almost instantly when reverse bias is applied. So because there is no charge carriers or holes, so while reverse voltage or reverse bias is applied means it will not come back to the opposite direction, so it is blocked. So because of this reason you can utilize this Schottky diode in high frequency applications. Then efficiency gap working principle and the thermal impact is so the Schottky diode, then standard silicon diode, a difference between the forward VA characteristics. So standard Schottky diode is it rapidly increases because very low barrier potential, that is 0.3 voltage. Then for standard, that is 0.7 to 8 volt for barrier potential. So because of this voltage difference, in thermal simulation, 54 degree, around 54 degree is generated, degree Celsius heat is generated in the operation of standard silicon diode. But in Schottky diode it is around it's like 38 degrees Celsius only generated. So it will not heat more when compared to the conventional PN junction diode. So power, that is equal to we know that volts in amps, then Schottky's voltage, that is 0.3 volt to 0.5 volt only. Forward drop makes it vastly more thermally efficient way to rectify the current. So this is the main advantages of the Schottky diode. The components comparison between the Schottky and silicon. So standard silicon PN junction metal semiconductor. Here new voltage is 0.6 to 9 volt, 0.9 volt for PN junction. It is 0.2 to 0.5. Reverse leakage currents near 0 microamps. So here noticeably milliamps at temperatures. Then max voltage, there is high up to 1000 volt. Low, it's very low voltage is typically less than 50 volt. Cost is very low, slightly higher on Schottky diodes or Schottky barrier diodes. When compared to the rectification efficiency, when compared to conventional PN junction diode, it's a very clean rectification. It gives a very clean rectification. That's the frequency range 300 kilohertz sine wave. That is a clean rectification operations will happen in the Schottky diode. But in reverse recovery delay, so silicon falls to the block current instantly at high frequencies. So it works in the high frequency also. Schottky diode works in the high frequency also, but conventional PN junction diode will not work properly. So some of the applications of Schottky diodes, that is solar voltaic panels, we can utilize this Schottky diode to block the leakage current, reverse leakage current. Then switch mode power supplies, that is SMPS, we can utilize this Schottky diode. And then digital logic gates also we are utilizing this kind of Schottky diodes. So thank you for watching this video. Thank you.